Okay, so in this video, I am going to discuss these two dot points, 7.4 and 7.5, which has to do with homologous series. Very, very simple concepts, hopefully. So this is a definition of a homologous series, is a group of carbon compounds in which each member differs from the previous member by CH2. So just to give you an example, let's say I have CH4 and then I have C2H6. So to go from CH4 to C2H6, I actually have added CH2 to the longest carbon chain. Now, if you have CH2, you cannot add it as a branch because a branch is supposed to be CH3. So the only way to go from one member to the next is to growing the longest carbon chain. And then from C2H6 to C3H8, I'm adding another CH2. And then from C3H8 to C4H10, I'm adding another CH2. So essentially what we have here are the first four members of a homologous series, and each member differs from the previous one by CH2. The second feature of a homologous series is that members of the same series will have the same general formula. We're going to talk about the general formulas in a second. So for now, just know that they have the same general formulas. And the reason for that is because the only difference between them is CH2, so you should be able to generalize it. Third feature is that they would have similar chemical properties. And the reason for that is because they have very similar bonding structures. So the only thing that differs one member from the next is how many carbon and hydrogen atoms that each member has. So if this one can actually this one cannot do much. So anyway, whatever this molecule can do in terms of chemical properties and reactions, this one can do. We haven't actually talked about chemical reactions at all since the start of the year, and we're going to start discussing chemical properties on Wednesday. For now, just remember this. And lastly, there is a gradual change in the physical properties as more carbon atoms are added, and we're going to discuss physical properties of homologous series in the next video. Okay, so alkanes, which we looked at last week, is an example of a homologous series in which each member differs from the previous by CH2. And yes, everything contains only single carbon-carbon bond. This is a general formula of an alkane, CnH2n plus 2, for N being the number of carbon. So when N equals to 1, you have CH4. Hang on. Yep, I knew this was going to happen because I forgot to leave some space in. Alright, so number of C. So this is N equal to 1, you get CH4. If it N equals to 2, you get C2H6, and then N equal to 3, and then N equal to 4. So CnH2n plus 2 is the general formula for an alkane, straight chain alkane. Even non-straight chain, but straight chain alkane. Okay, since alkane only contains single carbon-carbon bonds, the molecules contains the highest possible amount of hydrogen atoms. So there's a name for this. This is called a saturated hydrocarbon. So it is saturated with hydrocarbons. You cannot possibly take any more hydrogen atoms than the amount that an alkane takes. So an alkane is a saturated hydrocarbon. Or sometimes people just say it is saturated. So saturated just means that it has taken all the highest amount of hydrogen atoms possible. Okay, moving on to the second homologous series, which is an alkene. So again, when you go from here to here, you're essentially just adding a CH2. Also a homologous series in which each member contains at least one double carbon-carbon bond. Now, once you have alkenes and alkynes, it's actually a little bit more complicated. We're just going to look at one of the multiple series of alkenes that you can have, but in this case, if there's only one carbon double bond, then this is going to be the general formula CnH2n. So in this case, the first member is when n equal to 2. You cannot have an alkene that only has one carbon atom because you need to have a CC double bond for it to be an alkene. So, and then this is when n equal to 3. So you have C2H4 and C3H6. So if I remember the general formula, I should be able to work out how many hydrogen atoms I need if I know it's an alkene fairly quickly. So the number of hydrogen atoms will be double the number of carbon atoms, and that really helps. So you don't have to draw it out. If I have like 7 carbon atoms, you have to draw it out and count. Anyway, alkenes are considered unsaturated hydrocarbons because it doesn't, well, they don't contain the highest amount of hydrogen atoms possible, because alkane contain the highest amount possible. So if you look at an alkane, maybe I just write it here so I don't have to go back. So if you just look at an alkane that has 2 carbon atoms, it will have a formula of C2H6 because it's CnH2n plus 2. Whereas in the case of alkene, it's C2H4. So clearly there are 2 more hydrogen atoms that 2 carbon atoms potentially could take, but they're not there in an alkene. Therefore, you consider alkenes to be unsaturated. Lastly, we're going to look at alkyl, also a homologous series in which each member contains at least 1 triple bond. We don't look at alkyl a lot, like at all, like ever, even in year 12. Year 12 is just mainly year 11. I will take that back. It's not in year 11, but the organic bit is not that much more complicated. Also, probably should take that back. Anyway, if one triple carbon-carbon bond is present, then the alkyl can have this general formula. So essentially, hopefully you see a pattern here. If you go from alkane is CnH2n plus 2, and then you get to alkene, which is CnH2n. So if you form one carbon-carbon double bond, you're going to lose 2 hydrogen atoms. And then if you form another carbon-carbon bond, so you get a triple bond, you lose another 2 hydrogen atoms. So something like that. So every extra carbon-carbon bond that you form, you're going to lose 2 hydrogen atoms, which I think if you think about it makes sense. Okay, also unsaturated because it doesn't contain, well, they don't contain the highest amount of hydrogen atoms possible. So all you need to know is the homologous series, alkanes are saturated, alkene and alkyl are unsaturated. And for those who have heard of the terms saturated fat and unsaturated fat, which I think a lot of you have, it actually means the same thing. So a saturated fat or lipid essentially doesn't have any carbon-carbon double bond in the chain, and an unsaturated fat would. So create what's called a kink. I don't know whether the bio people have looked at this yet. But yeah, so unsaturated lipid just means that you have some CC double bond, probably not CC triple bond, but it could be, but I've never seen it before. And it could have more than one CC double bond. So that will vary the degree of unsaturation. So this is a mono unsaturated fat, and that's a polyunsaturated fat. But anyway, that's it for this